Hello everyone, my name is Nida and I'll be talking about the distinctions between substrate level and oxidative phosphorylation. An important reminder for this video is that cellular respiration will use both. However, oxidative phosphorylation will only work in aerobic conditions, while substrate level can work in both anaerobic and aerobic. To get a better understanding of the differences between both, I'd like to define what substrate level phosphorylation is, and it is the enzyme catalyzed formation of ATP by direct transfer of a phosphate group to ADP from an intermediate substrate in catabolism, chapter 7.1. In an easier way to understand that is a substrate, or the reactant on which an enzyme works, will activate the enzyme to create ATP. It is a very direct and quick process in the creation of ATP. Two examples of substrate level phosphorylation are glycolysis and the citric acid cycle. And we'll focus on glycolysis, specifically the energy payoff phase. During the energy payoff phase, 1,3-bisphosphoglycerate is created, and it'll have two phosphate groups. Usually a kinase, or the enzyme, is going to take the phosphate group and directly transfer it to ADP, creating ATP. And the next process will be using the new molecule, 2-phosphoglycerate. And it'll do the same. A kinase will transfer the last phosphate group to ADP, therefore creating ATP, and that's when the energy payoff phase creates 2 ATP. As you can see, it doesn't create a lot. It's actually a very small amount. Together, both glycolysis and the citric acid cycle will only make 4 ATP in all of cellular respiration. Moving on to oxidative phosphorylation, it is defined as the production of ATP using energy derived from the redox reactions of an electron transport chain, or the third major stage of cellular respiration, chapter 7.4. And there are two definitive points of oxidative phosphorylation, which is the electron transport chain and the ATP synthase. The electron transport chain is where it's a sequence of electron carrier molecules, the membrane proteins, and they'll shuttle electrons down a series of redox reactions that release energy to make ATP. The two electron carriers will get rid of their electrons, and it'll come down to they'll lose their electrons and transfer it to an oxygen that is waiting at the end of the electron transport chain. While the electrons are being passed down and shuttled, they are creating a flow, and that flow will ultimately help the process of osmosis. It is the movement of ions across a selectively permeable membrane down their electrochemical gradient. And the electron flow will help the hydrogen protons move across the inner mitochondrial membrane. And since there is a difference in between the gradients, they will want to come back, obviously. And the way that they come back is through the ATP synthase. And that is what really creates most of the ATP. The protons will shuttle down the protein complex, and it'll activate it, therefore creating ATP. It is a very indirect process, and it's not as direct and quick as substrate level phosphorylation. So the big takeaways of the differences between substrate level and oxidative phosphorylation is that substrate level will create ATP by directly transferring a phosphate group from these high energy molecules to ADP. using the enzymes. In contrast, oxidative phosphorylation is an indirect process that generates ATP by using the energy from the oxidation of NADH and FADH2 in the electron transport chain to pump protons, which then flow back to power ATP synthase. So another thing would be their energy source, which substrate level will use free energy released from the reactions, and the oxidative phosphorylation will use the energy from the electron carriers to power the electron flow between the electron transport chain. Another thing about between the two is that oxidative phosphorylation will make 90% of ATP, usually between 28 to 32, and substrate level will only make a little bit. It's like 4 ATP between two processes. And the thing about substrate level is that glycolysis is obviously in the cytosol, and the citric acid cycle is in the mitochondria. They operate in two different locations, and oxidative phosphorylation is in the inner mitochondrial membrane. That's also important to remember between the distinctions. And the last thing I would say is that oxidative phosphorylation obviously will need will require oxygen to be the final electron acceptor. And substrate level phosphorylation doesn't need oxygen. It just needs an enzyme and ADP in the area, phosphate groups. So those are the major takeaways from both, and that's the end of the video.